Hi, and welcome to Inequalities, where the unknown is in the denominator. Here we're asked to solve 6 over x plus 3 is greater than or equal to 1. There's going to be a couple of methods, so you're going to be able to choose which one you like. We start this method by realizing that x plus 3 can't be equal to 0, because we can't divide by 0. This means that x is not going to be able to be equal to negative 3. Next, what I'm going to do is I'm going to solve 6 over x plus 3 is equal to 1. This is just going to get rid of the idea of the inequality. We're going to ignore it just for a moment and get a solution. So by multiplying both sides by x plus 3, we get 6 equals x plus 3. And then subtracting 3 from both sides gives us another value that x could possibly be. X could possibly be 3. These two values are going to be important because what we need to do now is place those two numbers on a number line and test values either side of it. So I need to test something that's less than minus 3, between minus 3 and 3, and greater than 3. I'm going to start off by testing x equals minus 4. Now when x equals minus 4, I get 6 over negative 1. That is definitely not greater than or equal to 1. Next I'm going to test x equals 0, a nice number between minus 3 and 3. And this gives me 6 over 3, which is definitely greater than or equal to 1. Lastly, I'm going to test a number greater than 3, so I'm going to test 4. And we get 6 over 7, which is a proper fraction, that is definitely not greater than or equal to 1. What this gives us now is my solution. X is going to exist between minus 3 and 3. The important point about this value is that x cannot be equal to minus 3, so make sure that the inequality displays that. Now method number 2 comes from the idea that you can't just take an inequality and multiply both sides by the denominator, because if that denominator happened to be negative and x plus 3 was negative, then the inequality would flip and switch directions, and we don't want to accidentally lose one of our solutions. So what we do is we solve for 6 over x plus 3 is equal to 1, but instead of multiplying both sides by x plus 3, which could possibly be negative, we're going to multiply both sides by x plus 3 all squared. This means that we are multiplying by a number that is definitely not going to be negative. Simplifying this, if we're comfortable with the algebra, we're going to get 6 outside of x plus 3 equals x plus 3 all squared. Subtracting 6 outside of x plus 3 from both sides, we now need to factorize out a common factor of x plus 3, and then we're going to simplify. This solution now gives us two values, plus 3 and minus 3, that we can now check on a number line. So we're going to do that. We're going to do the exact same method. We're going to test either side of minus 3 and 3, and this will give us our value the same as the first method of x is between minus 3 and 3. The only thing you need to think about with this solution is that less than or equal to symbol. Make sure that you test those boundary values in the equation just so that you know that it's not going to be or equal to. And that's how you solve inequalities where the denominator has a pronumeral in it. Good luck.